Hi, in this short demo, I'm showing a very simple but useful lab setup with a Raspberry Pi. I generate a square wave using Python, measure it on an oscilloscope, and then verify that the measured timing matches what the code produces. Here is my setup. Raspberry Pi 3 B+, connected to a breadboard using a GPIO ribbon cable. That's the ribbon cable, and the T extension board. This makes it easy to prototype and run experiments without touching the Pi pins directly. For this test, I'm outputting a square wave on GPIO 23. The oscilloscope probe is connected to GPIO 23, and the ground clip is connected to Raspberry Pi ground pin. That's the oscilloscope. Here is the Python script. It turns the pin on, it waits 5 milliseconds, then turns it off and waits around 5 milliseconds. That makes one full cycle 10 milliseconds, which should produce a 100 Hz square wave. I run the script now, and let's observe the wave. Okay, so you can see now it's already captured. Now what we can do, let's stop the script. Okay, I'm gonna stop the script and I'm gonna restart it. You see? It stabilizes. Okay, so now we can proceed with the readings. We can see a clean square wave. And here you can see the oscilloscope is set to 2 milliseconds per division. One full period on the screen spans about, let's count them, 1, 2, okay. So 1, 2, 3, 4, 5. You see, that's the period. 5 divisions. 1, 2, 3, 4, 5. Here is the calculation. Period equals 2 milliseconds per division multiplied by 5 divisions, which would give us 10 milliseconds or 0.01 seconds. Frequency is 1 divided by the period, so 1 over 0.01 gives around 100 Hertz. Here I have a simple calculator that gives us the frequency. So the period is equal to 2 milliseconds per division, and we have 5 divisions. Let's update this. So the readings is 2 milliseconds, number of divisions 5, and let's save it and run it. Now let's save it and run it.